Hello guys, in the last couple of videos we did two graph based problems, DFS as well as BFS, and today we are going to continue with graphs with another very popular interview question, which is to detect cycle in an undirected graph. This is actually an application of DFS itself. It is asked by multiple companies including Amazon, Oracle, Samsung, Microsoft, Adobe and all. So let's get on with it. So before we actually discuss the algorithm, let's take a look at what a cycle in a graph means and see how the algorithm is supposed to work. How can we approach the problem? So as you can see, I have given four graphs over here. The first graph, you can see that there is no cycle in the graph. So cycle basically means a loop in the graph, and this is not, the first graph doesn't have a loop. It is obviously a tree, so there are no loops. Hence we can say that the first one as well as the second one, graph B, is acyclic, whereas graph C as well as D has a cycle in it. You can see there's a edge from 1 to 2, 2 to 3 and 3 back to 1. Hence it forms a loop. Hence it is a cyclic graph. And in D, even though it is disconnected, one component, at least one component of it is having a cycle. Because of that, the whole graph is considered to have a cycle. So the basic way to approach this problem is by using DFS. So you can apply DFS starting from the vertex that is given to you. In this problem, we are using the starting vertex as 0. And as you are going through in the DFS process, if you see a vertex which is already encountered in the DFS, then you can say that there's a cycle in the graph. For example, let's consider the first graph. In this graph, as we are moving through the DFS, let's say we start applying DFS from the vertex 0. So we mark this vertex as visited, then go to the first vertex, we mark it as visited as well, then it make DFS calls to 3 and 2, that's also made visited. Then it initially makes a call to 3, then 3 makes a call to 4, then only in the end 2 will be marked. So as we can see that during this process we don't see a vertex that is seen again. We don't see a vertex multiple times. Because of that, we can conclude that there is no cycle in the graph. Similar thing happens in the second graph as well. But consider the case of graph C. Here we start with this vertex. Let's say we are starting to apply DFS on vertex 1. It will make a call to 2. It will make a call to 3. And 3 makes a call to 4. And then 3 makes a call back to 1, which will indicate that there is a cycle in the graph. So such a call, it is sufficient to say that there is a cycle in the graph. So that condition is what we are going to check in our code. And there is one edge case to this problem, that is when we are, let's assume the case of this graph, graph B. So there's an edge from 1 to 2. Let's say we are making a DFS call on 1 initially. So we'll iterate through the adjacency list of vertex 1. So it just has 2. And it will call DFS for 2 since it is not visited yet. So now 1 and 2 is visited. And when we are iterating through the adjacency list of 2, we already have 1 over there. Because of that, it will say that okay, there is a edge from 1 to 2 and 2 to 1. Because of that, there is a cycle in the graph. But actually that's not the case because it is not having parallel edges. And because of that, we'll have to handle it separately, and that can be done by using by passing a parent in our Dfs function call. Before saying that there is a cycle in the graph, we'll have to check the vertex that is seen again is not the parent of the current vertex that we are exploring. So if we make this check as well in the function, that should get our job done. So that is the whole idea of how to implement, how to figure out if there is a cycle in a graph by using DFS. So let's get on with the algorithm now. Let's code it out. So if you want to take a moment and try to code it on your own or process something, go ahead. Take your time. So initially I'm going to make a map. You can simply use a vector as well, because in this question the vertices are given from 0 to n-1. Because of that, you can simply use a vector or an array to do it, but I'm using a map for convenience. I'm using an unordered map. I hope you're already familiar with that. I'm going to have the data types int for the vertex and bool for denoting if it exists or not. I'm going to name it visited. And after that, I can make a DFS call for all the vertices which is not seen. So I'm going to put in a for loop. So we did not see number of vertices, so I'm gonna give I less than v, I plus plus, and I'm going to make DFS call if it is not seen. If not equal to vis of that vertex, which is I, then I'm going to make a DFS call. And in the DFS call, we will have to pass certain parameters. First one would obviously be the vertex at which we are making the DFS call. So that will be I. And then we'll pass the adjacency list, which will be ADJ. And then we'll have to pass the map that we just created, VIS. And we'll need one more parameter, which would be the parent. So I'm going to call it, so here, for this vertex, we don't have a parent. Because of that, we can simply pass -1. And the reason why I'm passing -1 is -1 is not being used in the graph. So the starting vertex will be 1, 0, and it will just increase from that. It won't be less than 0. So we can just pass in -1. And in the end, I'm going to return an answer variable. Just create the answer, return answer. So yeah, I'll declare this variable globally, or you can pass it as a parameter. Actually, it is not very much of a good programming habit to actually make a lot of things global, but for the sake of convenience, I'm going to do that. So I'm going to initially declare it as false. This variable detects that if there is a graph or not. Initially, we are saying that okay, there is no graph, and if we detect a cycle, we can change this variable back to 1. So now we can implement the DFS function. It will have a return type of void, and in the DFS function, we can declare the vertex that we are iterating, which we are exploring. That will be let's say x. Then vector, we need a data type for adjacency list. So vector int adj, will give the same name. Then we need a map, unordered map. If you don't know what unordered map is, you can check out Geeks Week's official page to get more info. Int and bool, and we'll have to pass the map by reference, not value. And we will need one more value to act as the parent. So that would be the parameters for the function. So as soon as you see, there is one thing that we can do over here to make our algorithm a little more efficient. That is, we can check that if answer is made true. If answer is made true, we can simply return. So that will make our algorithm a little more efficient and fast. The reason why we do this is that if we already detect a cycle, there is no point in making the DFS calls again, because if you already know there is a cycle, we can simply return from that point itself. That's why I'm just putting a statement like this over here. And once we are done with that, we can actually mark that vertex visited. So once we mark the vertex visited, then we can make another variable, actually int m. So that will denote the size of the adjacency list of the current element. So that will be adj of x dot size, and now we can iterate through the adjacency list of the current element. For and as we are iterating through the adjacency list of the specific vertex that we are exploring, the current vertex that we are exploring, and we can check if it is already visited or not. If not equal to, let's see, if it is visited, then we can make another check, that is adj of I comma x comma I, and not equal to. If it is not equal to parent, then we can say we can make the answer variable true, because that's a cycle. So variable is 1, and we can simply return from over there. And if it is not the case, if it is not visited, then we'll have to make a DFS call. So else we can make a DFS call for the current vertex. So that will be adj of x and I, and we can pass in the parameters. Obviously we have the adjacency list, map, and we have a parent variable, which would be the current vertex that we are exploring. that'll be X. And so it's not map, actually. I gave the name visited, so I'm gonna make it visited. Yeah, okay, I think that is all. So this also should be visited. So visited of a ADJ. So when we iterate to the adjacency list of the current element that we are exploring, we check if it is visited or not. If it is already visited, then we also check if it is not the parent of the current vertex. If it is also not the parent, then we can obviously say that there's a cycle in the graph, and you can simply return from over there. And if it is not visited, then we can make a DFS call to that vertex. Let's see if it works. So it works for the sample test case. Let's try and submit it. Yep. Okay, that's it. So we have successfully completed the algorithm to detect a cycle in an undirected graph. So we'll be doing a couple of more graph problems in the next couple of videos, and after that we will move on to an entirely different topic and do some problems based on that topic itself. If you have any suggestions on what topic I should take for this, you can post down in the comment section below. I'll take that specific topic and do some problems based on that. And I'll also be creating a roadmap video on how to crack technical interviews and all, and you can expect it very soon. So until I see you guys in the next video, bye.